Hello students, we'll discuss about the concept of free electrons today and what are free electrons. Before that we should know what are electrons, and let's quickly have a look on structure of atom. So as we know that in the structure of atom we have a nucleus. Inside nucleus there are neutrons and protons. Neutrons are neutral, protons have positive charge. So nucleus will also have positive charge and electrons revolve around the nucleus in orbits, right? So we can find electrons here, and electrons are negatively charged. So when we move from the boundary of nucleus towards the outermost orbit, so as the distance increases, force of attraction between electrons and nucleus decreases. So electrons, those are in outermost orbit, they are loosely bound with the nucleus. So what happens is here these are the nucleus, this is the nucleus, like these all are nucleus, and red dots are showing electrons, and these are the electrons in the outermost orbit. So these are loosely bound electrons. So what happens is, because they are loosely bound, they can easily jump from the outermost orbit of this nucleus to this nucleus, and again from this to this, like that. They can easily move from one place to another throughout the material, and sometimes they forget that which atom they belongs to. So this is how they can easily move, and these freely moving electrons are called free electrons. So this is the concept of free electrons, which is very easy, and the conduction is due to free electrons. Like we say, this material is good conductor of heat and electricity. So the material is good conductor because of free electrons, because free electrons carry energy in terms of heat. Now the next thing is, what is drift velocity? So this is the definition: the average velocity with which free electrons move in a steady state opposite to the direction of electric field in a metal is called drift velocity. So point to be noted, that the direction is opposite to the direction of electric field, right? So here we'll have a look on this diagram. Here these are the electrons, right? And this is the direction of electric field. So we are applying electric field towards the right hand side, and electrons are moving towards left hand side, which is opposite to the direction of applied electric field. So this is how, so this velocity of electrons is known as drift velocity, and we denote it by Vd. D is in suffix. Now how can we find out the expression for drift velocity? So we'll consider this diagram only. Here electric field E is applied, we have already considered it, and the mass of the material, the metal, piece of metal which we are using is small m, and charge is small e. Now this charge will experience a force. The basic definition of force, F is equal to negative of EE. The basic definition is F is equal to QE actually. So Q is the charge. Here we are using E, small e at the place of E, because this is about electron, and in case of electron we use small e at the place of small q, and this negative sign shows the opposite direction, right? So that is why we are using opposite sign, negative sign. Then the resistance force offered to its motion is, this is the formula for resistance force, mv by tau. Tau is the mean collision time, and Vd we are using at the place of V because the velocity of electrons is nothing but drift velocity. So mvd by tau. In the steady state, these two forces should be equal. So we'll equate them. Fr is equal to F, and we'll paste the values, and we can find out the value of drift velocity. So this is the formula for drift velocity. The next thing is thermal velocity, and the definition is that thermal velocity or thermal speed is a typical velocity of the thermal motion of particles which make up gas, liquid, etc. Thus, thermal velocity is a measure of temperature. So, thermal, the name only represents that it depends on, it is related to temperature. So, this is the formula, square root of 3 kT by m. T is the temperature, m is the mass of the piece of material, k is the Boltzmann constant. And because k is a constant and mass is also constant, mass always remains constant, we know that. So, 3 is also a constant, a number. So, we can say that thermal velocity depends on temperature, square root of temperature actually. So this is all about thermal velocity.